So first of all, what exactly, why we need Web3 and all this stuff? So first we need to understand some of our past things, what exactly we have done and how the internet is evolved basically. So in our past, like around 2000 and before, like before cancer, it was all about Web1 where you can, everyone knows I know, because the Web1 is basically static website and all these static things. You cannot interact all these things. So this is past and present. We are using Web 2.2, which is your Instagram, LinkedIn, Twitter, all these where you can interact, where you can post your thing, you can do everything. So in the future, or you can say we are evolving towards the Web 3.2, and we're gonna see what exactly this Web 3 is. So before that, let's just learn something that how the internet is evolved. So in 1960s, there was a small project called AlgoBharat funded by US Department. Basically, they have created this project to survive the nuclear interactive crack and all these things. So this was a small project when the internet basically came to the ecosystem or to the people. And after that, in 1980s, we saw the www, which is World Wide Web. So Tim Berners-Lee invented the www, and which allows for easy sharing information. You can post basically not everybody, but yeah, like companies can post things on the internet and others can access this thing. So that exactly is www, and the first website went online in 1990. It is not this is still, you can say just how many, 24 and 9. It's not very much. So yeah, still we are evolving and we are moving towards Web 3.2. So early internet is Web 1, like I've already mentioned that Web 1 was the first internet we access, we see, and we use basically. I guess everyone uses Web 1, like Wikipedia. You can say some static website. Can anyone give me an example of some static websites? Web 1. Any website name you have seen? Can anyone give some examples? Like there are a lot of things. Yahoo, you can say it was based on one, like Netscape, Britannica, and all these websites are based on Web 1, right? So these websites were statically, like you can say, very static, and sites are limited to text, images, links, and all these things. You cannot interact, you can just consume, basically, one way. And there are always some advantages of some, like if there is an advantage, there are some advantages and there are some disadvantages. Right. So advantages of Web 1 is easy to create, maintain, because they are static. You don't need to do everything like boosting and all these things. So you can maintain easily, right? You are not putting so many content on it. You are not storing data and all this. And that's why it's easy to load and navigate. But disadvantage was not interactive, right? Or user-centric and limited to plain text, images, and links. You cannot put some animations and all this stuff. So these are some advantages of Web 1. And after that, people just need some new technology where they can use and manage things on their own. So after that, Web 2 came into picture, and this is basically interactive web we are using nowadays. So like all the social media apps we are using, Instagram, Facebook, and all this stuff. These are all Web 2 websites, right? E-commerce, Amazon, Flipkart, where you are buying, selling all this stuff. So what exactly the difference between these are? Like you can, for example, Instagram, you can put your own content, right? So this is dynamic, where a user can put photos, videos, and all these articles. You have power to put, right? But in Web 1, there was no such thing. Like some companies have, you can say Netscape, they have the Web 1 website, and they are only putting, and people are consuming that. So, but now Web 2 gives the freedom to post, or you can say give the user freedom to post stuff, whatever they want. So advantages, yes, of course, there are some few advantages and few disadvantages of it. Advantages are it was interactive. You can interact, you can connect to other people's user experience. Like the amazing website, right? Like smooth and easy to do, personalized content and recommendations. But there are two disadvantages also. So centralized control, ownership of data. Like they have all the access of your data, right? They are storing our database. Privacy and security concerns. Yes, like it's most important thing, security concern, because you may heard, I guess, I guess 2 years back, Twitter banned Donald Trump Twitter account, right? So like they can do it, the president. So you can just imagine we are just normal people. So that's the problem. And also you may heard that data is leaked from Domino's, all the addresses, all these things. Also, more Facebook data, WhatsApp data are leaked and all this stuff. So these are some concerns in the Web 2 internet. So after that, internet get more evolved and new technologies came. Now we are moving towards Web 3. It's a decentralized web, we can say. And Web 3 is the latest phase. We are currently building, using, we have seen a lot of decentralized application, decentralized, you can say, exchanges and all this stuff. We are still building decentralized social media. People are building everything on decentralization, right? Like just still building this. So what exactly decentralization gives us? It basically empowers users with increased security, reduce security, because in Web3 we are using different cryptographic techniques, encryption methods, and all these things. And it also gives the user control over their own data. Like they can own their data. There should be like there will be not any third party or any central DB and all these things, so that you have power to put things on the internet and it will not be created by some central databases, central authorities. And it also allows to peer-to-peer interaction without intermediary, right? As we know, decentralization means there is no centralized body which controls you, but it's connected over nodes. You can say different nodes, it will be connected. And based on that, you can interact. Peer-to-peer interaction, right? So, of course, there will be some advantages and disadvantages of this technology also. So, advantages are decentralized control and ownership of data. You have data ownership, and security and privacy is increased because we are using some latest technology, some cryptographic method, which I will discuss in further slides. Censorship, resistance, and transparency. Yes, of course, because since Web3 is using blockchain technology and many more things, so it's transparent. There's no, can say, if I take example, like if I have an NGO and I'm like someone is donating to my NGO and like they don't know where the money goes, where the flow is. So using the Web3, using the blockchain technology can be transparent, it can be trackable, right? Where all these amounts is going, where are the NGO is spending also, right? So it also empowers users with control over their data and identity. Yes. So currently, Web3 people are building a decentralized identity, at least with a ZK integration. So these are a few advantages of Web3 and disadvantages, or you can say opportunities, yes, because disadvantages are things you can convert to make it like if there is some disadvantages, there are opportunities, right? You can remove these disadvantages by making some solution for it. So it requires new infrastructure and technologies because this is evolving technology, this is emerging technology. So there are a lot of things you can build, you can explore, and for all these things we need new infra and new technologies for building all these things on Web3. And maybe less user friendly and accessible to non-technical users, because this is right, because not everyone is in India, you can say there may be people that are not non-technical, so there can be some issues while accessing all these things, because it requires in Web3 we use high security, right? We use decentralized wallets, decentralized things. So, maybe less user friendly to the non-technical guys, but yeah, if we encourage people and if we talk about Web3 or blockchain, so maybe in a few years this will be easy to use to everyone, like whether it's technical or not technical, right? So what is the difference between centralization and decentralization? So in centralized body, controlled by central authority, all our data ownership and all these things are all controlled by central authority, as I already mentioned about the Twitter account ban. Donald Trump Twitter account got banned by Twitter. So they hold all the authority, they control everything, so they can do anything for it. Like they can sell your data, they can use it, right? Data vulnerabilities, censorship risk, privacy violations, and all these things. Basically, centralized system with things. These are risks, basically, you can say. So some centralized bodies are Meta. Meta is Facebook, and a lot of centralized application, Twitter, LinkedIn, all these are centralized application, right? And in decentralized body user have control over their own data, they have ownership, and its storage is distributed. It's not stored in some single databases where the central authority or the owner of that particular company have access, but it's distributed storage. In decentralization, we are using distributed storage. Your data is stored and you can say it's distributed at different nodes, different computers. There is no central database. So that if that database got destroyed every day, like the data got destroyed, so in decentralization, not these things will happen because they are using distributed storage. And it's censorship resistant and privacy protection is there, because I've mentioned that we are using amazing technologies over there. So some of the examples of decentralization, or you can say decentralized bodies, are Bitcoin. Bitcoin is a decentralized blockchain, and Algorand is also layer 1 decentralized blockchain where you have your ownership. So let's talk about what exactly is blockchain. I have discussed many things about decentralization and all these things, but what exactly is blockchain? So blockchain you can define in just one line. Blockchain is a distributed, transparent, immutable ledger. So what exactly this means, distributed? So distributed means your data is divided, you can say, not exactly divided, but you can say, let me explain by an example what exactly I am saying distributed. So let's say this is a database, right? So distributed means I've created multiple computers, multiple databases over here, and all these databases are connected to each other, right? So all these are connected to each other, and like don't don't get these arrows, these are both ways, right? You can, like, this is connected to this is connected to this, and this is to this. So yeah, something like that. So this is you can say a structure where all these computers are connected to each other, and you have some data. These are databases, right? So let's you have some data. You have code over here, right? This is your Facebook account. Yes. So distributed means this data. This is users' data, my data. So my data will be like, if I'm putting it in a blockchain. Blockchain is a distributed technology, right? So my data will be went to every node. It will not be in a centralized database, but it will move, or you can say it will be shared amongst peer-to-peer nodes. Every node will have that copy of my data, so that if I like someone switch off this computer, this node will be turned off, or you can destroy it. I can access my data from other computers, right? So this exactly means this distributed system, where your data is distributed among different nodes, different computers, you can say, right? So this is distribution. Like the word itself says, distributed means it's distributed, not divided, because divided means your data divided into chunks and all this stuff. So this is basically all the computers have the copy of your data. This is the distributed system, right? So okay, let's transparent. So blockchain is a transparent technology. Why I'm saying transparent is you can track all the things. Let me also explain by an example. Let's say to explore what's trending. So this is an Algorand Explorer where you can track all these things, the USDC, what is the flow and all this stuff, right? What is the total supply and all transactions, who are doing transactions, where the amount is moving. Like you can see, like this is some, this is blogger central receiver. Yeah. So you can see that $51 USDC someone transferred from this is sender to receiver. Basically, he sent some $51 to this address. So this can be trackable. So let's check this address. So you can see this address total balance of 1375,000 algos, and these are something asset created one, asset created all. You can track basically. And also let me share you the Ether scan. And let's say I know someone's address, right? Just let me copy my address. So this is my address, and I copied it to Ether scan. So as you can check, this is my address. If you know someone's address, you can track all their data. Like I have $71 of Ethereum, and I have 6 tokens, the NFTs and all this stuff. And you can also check my transaction, like my internal transaction. I have did some transactions 30 days ago, DK thing. 10-15 days ago on Uniswap router, I have something 0.2 Ether. You can track everything. Token transfer, where I transferred the tokens and all this. You can see. I have transferred 27 USD, 3,000, this token, this. So that exactly means transparency, right? You can track everything. 93 days ago, I have transferred this token. So if you want to go to the hash, or you can say, like, this is my address, 0x349. From where it came from, like these $27, who sent this? So you can also track their account. So this 0x, they sent some things to my address, so you can track their transaction also. They have done this transaction, and what they hold $27, all this. So this exactly means transparency, right? You You can track everything. This is transparent. Blockchain is transparent. You can track flow amount and also basically flow of data, because these are all data, right? And let me show you one more. This is transaction hash. So you can see all the details over here also. The transaction hash, you can see basically what the gas it cost, what time I did that transaction, which was 16, timestamp, and a lot of things you can explore. Similar to this algo explorer, you can track everything, right? And if I put my algo address, you can track, or you can, like this is an asset, basically asset address, asset ID. Sorry. So based on that, you can track all the data, right? So this is transparency, and it is immutable. Immutable is the most important thing. Immutability property of blockchain, that means you cannot remove anything you have put on the blockchain. If I did this transaction, I cannot remove this information from it. It will be here forever. You cannot remove. This is the beauty of this blockchain technology, right? And it's a ledger. Ledger is basically, this is a book where you store all these things. So non-technical definition is simply a database spread over multiple computers and secured by a network. So as I have shown you this diagram, this is a non-technical definition. You can say this is the distributed system spread over multiple computers. And this is DLT. DLT is not a new technology. People use this technology before also, distributed ledger technology. But after Bitcoin, Satoshi Nakamoto basically took all these technologies, DLTs, timestamp, cryptography techniques, and he made that blockchain thing, right? The first blockchain of Bitcoin. So what else? This decentralized distributed database recording all transactions in chronological order, right? Chronological, these are like if I did a transaction first, my data will put on the blockchain first, right? This is chronological order. So it stores data securely and immutable in the cryptographic sealed block. So cryptographically sealed block means all the data is encrypted so that no one can hack, no one can remove some information from that block. And block, I will explain what exactly the block means, because blockchain is made from two different words, block and chain. So basically, this blockchain is a chain of blocks. Consensus-based peer-to-peer network. So yeah, consensus is the most important thing in the blockchain, because here there is no regulatory thing. There is no central party who governs. There is no manager or some kind of thing that will do if some of their people, or you can say employees, doing wrong thing. There is no control over it, right? So these things are controlled by consensus mechanism. Consensus. Okay, let's go to next slide. I will explain what is consensus. So benefit of blockchain, there are a lot of benefits like its security, immutability property, transparency, trust, right? Decentralization, cost reduction, because you can send, I will also show you how you can transfer money and all this. So you can transfer amount in just few seconds and very low cost. Well, just need few gas fees. In efficient speed, traceability, accountability, global accessibility, innovation use cases, data privacy, resilience, security. Yeah, security is quite not a skill. It's very simple, right? Like someone will say that there are a lot of hacks happened in the blockchain, but these hacks you see not because of the blockchain fault, because of, you can say, smart contract fault, you can say breaches, interoperability breaches. Because all this stuff, there were hacks, not because of blockchain, right? There is a smart contract. So what exactly is smart contracts? Can you tell? People are not responding. Are you there? Everybody is there, right? Okay, so
it is a set of instructions executed in a decentralized way. without any third party intermediary.
Perfect. This set of information, right? Exactly. So yeah, also one benefit is fraud reduce. Basically, if you are doing something on blockchain, with very less possibility, minimum possibility of frauds. So there are a few type of blockchain. We study public blockchains, but there are also consortium private permission blockchains. In public blockchains, participation is open; anyone can participate. I'm showing an example of that Allo and Ethereum transaction, that is Algorand and Ethereum blockchains. You can track every data, everything. But there are also few other blockchains which are permissioned or private because of there may be let's start with public blockchain. So public blockchain are open to participation, right? Everyone can participate, can build, can use. Its secure is maintained for consensus. Consensus I have already mentioned. I will explain in detail what exactly consensus, but it's just you can say authority, or you can say some regulations which have to follow by everyone, so that the main it maintains all the progress and all these things. So that's why consensus is required. And there are some private blockchains which have limited access, visible only to authorized entities, greater efficiency paths of transaction. So why private blockchain? People are using the private blockchain like Ledger and all this inside their organization. If some, let's say IBM, they want to implement something, they don't want to show to everyone they are building something, they want to make it private, right? So they can use private blockchains so that not everyone got to know what exactly happening, but they limited access their employees because they are investing where they are building something, so they don't want to use to everyone, right? So they can use private blockchain. Consortium blockchain are basically operate for mutual consensus, two different consensus party, you can say, get together and they discuss that we have this property, we can actually collaborate, we can collaborate. So these are consensus blockchains. These are balanced network management structure, and a lot of companies sponsor their blockchain are used. Also collaboration within the trusted two different parties. As I mentioned this line, that it's based on collaboration, two different parties use their different technologies, different properties, and they can just collaborate and do it. Permission blockchains. So these are mandate identity verification. You have to verify your identity, who exactly you are. These are more secure and limit participant capabilities, ensuring control interaction and data integrity. Because there is a permission, right? You need permission from the higher authority that you want to use this. Not everyone can use. Compatible with traditional frameworks and ensure regulatory compliance. So, because as we know, there are a lot of companies which are 40 years old, 35 years, 50 years old. So, permission blockchains are compatible to these frameworks. They have used C# and all these things, Ruby on Rails. So, a lot of people also use permission blockchain. So, let's see some type of public blockchains. So, some are Bitcoin. I think everyone knows Bitcoin. Ethereum, Algorand, Solana, Litecoin, and ton of cryptocurrency blockchain. To show you coin market cap and can close these graphs. So these are the blockchains: Bitcoin, Ethereum, Binance, BSC, basically Binance, a smart chain, Solana, Ripple. These are stable coins. These are not blockchains. Cardano, Avalanche, Goon, Chainlink, Polygon, and all these hundreds of blockchains. People are building this. So you can also filter and you can search everything. You can just where was that? Okay. You can also filter based on proof of stake and proof of work. So you can explore this coin market cap where you can basically analyze different blockchains, different things, get aggregate. So in categories also you can see like different market caps and all this stuff. Okay, let's get back to it. So now let's see what exactly is consensus algorithm. So consensus protocol allows participants who may not fully trust each other to collectively agree on a state of blockchain without relying on single party. Like as I've already mentioned that in the blockchain, in decentralized network, there is no central party, right? So we have to make sure that not will betray or you can say hack someone node, someone computer and all these things. So you have to make some consensus protocol, consensus algorithm where people who may not fully trust each other collectively agree on a state of blockchain. So they have to agree. This is rules you have to agree. If you don't want to, you cannot participate in the blockchain. Right? So that's why consensus algorithm, consensus protocol are used. These are nothing but just set of rules that everyone have to follow. Everyone, if they are not, they cannot participate. Right? So consensus protocol. Consensus protocol ensure that all nodes agree on order of transaction. So each transaction can be validated and added to the blockchain. Yes, there can be a problem. So let me share one more example. So let's say these are few blocks. People are adding the blockchain, right? These are connected to each other. Okay, so there can be one thing that can happen. Let me connect this. These are all connected, right? These are connected blocks. This is block 1, block 2, block 3, block 4, right? So there can be a possibility because there are multiple nodes, right? Multiple people are adding blocks. So there can be a possibility that 2 people are adding blocks. Like let's say someone added over here, someone added over here. There can be a problem of adversary mode, you can say. It can be something like this. Blockchain is divided into 2 different blockchains. Right? This can happen, right? Because there are not a single entities adding the blocks, right? So the problem can arise is 2 multiple parties are adding the blockchain and this block basically thinks that yeah, this is correct and this is also correct. So they are dividing a single blockchain into different blockchains. So consensus protocol basically ensure that all nodes agree that the order of transaction. So each transaction can be validated and added to the blockchain only once. This is one thing of double spending basically, and I have explained this. You can say hard fork and soft fork. But this is also one problem that this can be happen that I have sent some amount, let's say I have sent 2 BTC to Akash and it's not updated and in my account is still showing I have 2 BTC, right? So these things can be happen. So consensus protocol basically ensure that all that transaction can be validated and added to the blockchain only once, right? There should be no double spending, some sort of things. The consensus also ensure that the network continues to operate even if some nodes are offline, faulty or malicious, right? Exactly this. Consensus also ensure that if some network or you can say this turns offline, so other blocks will have to work and they will participate in the blockchain. So consensus basically ensure all these things and also consistency. So consensus protocols ensure that all nodes have the same view of the blockchain. Right? Exactly. If someone is seeing this transaction, every node have that particular data on. Like not that this is some other data or something, right? So consensus ensure that my data is copied exactly same to different nodes also. So these are a few things, and also consensus prevent attacks. Basically, some adversary can some hackers can attack the blockchain and can try to you can say modify the data we have put on blockchain. So consensus protocol ensure all this. it solves competing chain problem exactly this competing chain problem. There should be only one chain which will exist, not these things will terminate by using few rules which are longest chain rule. I think I don't have enough time to cover all these concepts. So yeah, you can search longest chain rule. So by longest chain rule, consensus ensured that only one chain will exist, the final chain, right? So yeah, this will happen something like that. This will reject, this block will reject it, and only one full chain will exist. It also prevent double spending, as I mentioned. You can spend your tokens, you can amount only once. If you have sent something, it will some sort of UTXO-based model. Like if you send $2 to someone, $2 will detect from your account. So you cannot send $2, the same $2 basically, again. So that's exactly its double spending. Proof of work. It's a consensus algorithm where miners compete to solve a difficult mathematical problem based on hashing algorithm. So proof of work basically utilizes, you can say, proof of work is used in the Bitcoin blockchain. So for adding a new blockchain, adding a new block into a blockchain, you have to basically solve some cryptographic algorithm, some hashing algorithm, which is nothing but some sort of, you can say, you have like for become a miner, you have to be a powerful computer. We show you mining. Bitcoin mining. So there are a lot of companies mining the Bitcoin. So you like the hardware and all these stuff. You can see these are mining set of Bitcoin. You can imagine the power the computer needs to mine a blockchain. Right? These are a lot of database warehouses and all these stuff for mining the Bitcoin network. So yeah, you have like basically for mining a Bitcoin, you have to solve a mathematical problem, and then after miners receive rewards to solve this problem. Exactly. Like if I'm solving a mathematical problem and I'm basically adding some blocks, I have to receive. Right? That's what proof of work. You are working and you are proving yes, like then you get rewards, and the rewards are in the form of Bitcoin. And miners have to find the valid nonce value. These are some in-depth things. I think I don't have enough time to explain all these things. So okay, let's just finish all this in short. So nonce is nothing but a random number. So for solving these difficult mathematical problems, miners have to find a valid nonce. There are some limits of nonce. They put all the nonce values, different values, and in some particular nonce values, this mathematical problem got solved, right? So they have to find that nonce value. Once it's generated, it is very easy to verify the block. So once you have generated nonce, it will just verify that block and it will add to the blockchain. It needs high energy consumption. One fun fact, the energy required to, the energy consumed by Bitcoin in 1 year is exactly the energy consumed by some countries like Switzerland. Like the whole 1 year energy, the whole country utilizes exactly the energy consumed by Bitcoin mining and all this, right? So you can imagine the energy consumption of Bitcoin. So that's why new technologies, new blockchain, new consensus is required, because it's a high risk for our nature and all this. Proof of stakes, it is used by Ethereum blockchain. Ethereum was first on proof of work, but after that they saw this is very carbon emission and all this stuff. So they have moved to proof of stake. So it requires user to stake their money. So you have to stake some amount. Stake means you have to lock your amount in to be a validator, right? If you want to validate, if you want to add a block in the blockchain, you have to put you have to lock your money. Why we are locking? Because if you are doing something wrong, you are doing malicious activity, your locked amount will be lost. So that's why in Ethereum you have to lock some amount. And validators are responsible for adding confirming blocks, and a good validator receives incentives, right, in the form of Ethereum. So in the Bitcoin, they receives mining rewards, which are Bitcoin in the form of BTC. In Ethereum, they receive the form of Ethereum. So it's not easy to manipulate. To do so, a hacker needs 51% of the stake. So yeah, the whole Ethereum network, if you want to manipulate, you need 51% of the stake, which is impossible. Why impossible? It's question for you. Okay. Pure proof of stake. So pure proof of stake is next level consensus. Here also there are some problems with this proof of stake because here you are staking your money, right? If I'm staking, like let's say I've staked 10 Ethereum and Akash have staked 15 Ethereum, Akash will get more priority of adding blocks than me. So this is you can say moving to a centralization. If someone is putting more, someone is blocking more Ethereum, they are getting more chances to adding block in the blockchain and getting rewards. So what pure proof of stake is, okay, I guess we have session tomorrow also where we will discuss all these things. But yeah, this is advanced technology and you can say more advanced than proof of stake. Silvio Michele is the founder of this technology, you can say this consensus. He built Algorand, and also Silvio Michele is a founder of zero knowledge proofs, VRFs. VRF is nothing but a variable random function. You can generate a random function on chain and you can add your consensus basically. So I will discuss what exactly pure proof of stake is in our next session. Now let's see some decentralized wallet. Decentralized wallet are there are two types of wallets. You can say software wallets and hardware wallets. Software wallet, MetaMask, Trust wallet, Terra wallet, and the hardware are your ledger. And you can basically in the form of pen drive you can hold that. And basically, if you want to confirm some transaction, you can sign in your USB drive. So these are hardware wallet. The smart contract. Okay, so smart contracts are nothing but just automatically execute code over a decentralized platform. So smart contract are some, you can say, instructions which will be or which is meant to be executed when some certain conditions are met. So let's say I have a contract, as we already know what exactly a contract is, right? If I am purchasing a building or buying something, so I made a contract, right? That if you will give me papers, I will transfer money to your account. So I have written the form of a smart contract. So a smart contract will be stored on the blockchain. So the other party or maybe I can corrupt, right? So nor me and nor other property can corrupt because it's stored on the blockchain. I have signed the transaction. The other party have signed that thing. That yeah, we both are agreeing to this contract. So that's why it is smart contract. It's on the blockchain. That's why it's a smart contract, right? So when some certain conditions, some predefined conditions met, the smart contract will execute. Let's say I have written a smart contract where I have written that if the temperature of food I am receiving from different shop is less than 30 degrees, I will transfer that. That means I am purchasing some food or some fruits that is not bad. I will receive the food and the amount will be transferred. So I cannot be correct, right? Because the smart contract I have put on the blockchain. So if it will check the food is good, it will automatically transfer the amount. So these are good examples of smart contract. And then, in our next session, I will show you how exactly smart contract looks, how we can write smart contracts. So smart contracts are programs written by developers stored on EVM. EVM is basically Ethereum virtual machine. AVM is Algorand virtual machine. So smart contracts are stored on these things, right? So these are virtual machines, right? Some environment variable where all these instances are stored. The smart contracts are stored uniquely, and each smart contract has its own public address. When you deploy a smart contract, it generates an address, right? The address is, you can say, a link where you can check what exactly it is written in smart contract. Because it's all about transparency, right? So smart contract, when you deploy a contract, it generates public address where everyone can check. Or the instruction is written in the smart contract. So we as a user can interact with smart contract by submitting a transaction with some query. Once they are deployed, it is impossible to modify the code, right? Because this is a property of blockchain. It's immutable. If you have deployed, if you are putting something on, you have written instruction in a smart contract and you deployed it, you cannot modify it. That's the beauty. And in simpler terms, they are backend of your dApp, which get executed whenever some submits a transaction. Yeah, exactly. These act like dApp, backend of your decentralized application. So let's see what are the cryptocurrencies. As I've already shown you this website, these are all cryptocurrencies. Bitcoin is $51,000. One Bitcoin cost was $51,000. Can you imagine? Right? Ethereum and all this stuff you can check over here. Filter, customize, you can see everything, right? So cryptocurrency is an automated payment system having some properties, ability to show, ability to stop. You can basically use the payment media, report store and all this, right? So also let me show you one more thing. Let's say this MetaMask wallet. Just expand this. So these are few tokens I have, let's say desk and all this. So these are cryptocurrencies, and I have an ability to send, to swap, to bridge, and all this stuff I can do. So these are Dogecoin, BGM, and all this stuff. So these are cryptocurrencies, right? There are thousands of cryptocurrencies. Decentralized application, where it is stored on a decentralized network, or decentralized application, right? So decentralized application dApp is an application that runs on the blockchain or a P2P network of computers instead of single computer, right? So it's a decentralized dApp, decentralized application, right? It's not stored on a single blockchain, a single computer, but it's on a P2P network. Everyone have its access, and you can say instances its data, so that if some mode, some computer turned off, you can still access by other computers, right? So what are these apps? I think we don't have enough time. We have 3 minutes. Okay, I will extend 10 minutes. Don't worry. This is Saturday night. I hope everyone is free just for 10 minutes. And if you have any question, you can put in the chat box meanwhile. So DLTs can contain information beyond financial transaction, right? Let's say I have shown you all these things in regarding to transaction, all this, but you can use it in different ways. You can build a decentralized music application, decentralized online shopping application, right? So these are two things you can build a decentralized application. Not an idea people already knows about remote code execution and code injection. So these, as I've already mentioned, these are on the base of DLTs, and these are not new technology. People already know all these things, but Satoshi Nakamoto basically combined all these things and created a blockchain, new technology. But the base of blockchain, the properties of blockchain are people were using before blockchain also. So DAOs will go in the next lecture. Okay. This is the last topic. So DAO is nothing but, let's say I am working in a company and I have some ideas, right? I have proposed to my manager, but my manager didn't listen. He's not interested anymore in my proposal. So my idea got rejected, right? There is no value of my idea. But in the decentralized autonomous organization, what can happen? You can basically put proposal on a blockchain network, and the people and the community will vote whether your proposal, your idea is good or not. Based on the voting, it will select or deselect or reject this. So DAOs are nothing but decentralized autonomous organization. It's autonomous organization which is decentralized, right? So let's read this. Decentralized autonomous organization is an organization constructed by rules encoded as a computer program. Yeah. So people, or you can say community, have already written some restrictions, some rules that if you want to be part of this organization, you have to follow these rules. program that is often transparent, controlled by organizations, member are not influenced by central authority. Yeah, since it decentralized autonomous organization, why I've written this controlled by organization member? Because this is for an organization, right? So that whole organization will have control of that, not a single central authority, right? So decentralized autonomous organizations are on-chain entities that facilitate the governance and economic coordinations of decentralized protocols. And token holders is nothing but every DAOs have its cryptocurrencies. Like if you are storing, if you want to be a member of that DAO, you have to hold that token of that DAO. So based on that, you can vote, you can reject, you can accept the proposals, allocate budget, make decision on any proposed project idea, right? So these are some things. Like there are a few examples. Q blockchain is a new blockchain. They are focused on decentralized autonomous organization, and in Algorand also there are few things you can vote, like a proposal. If in the Algorand ecosystem people are building something, if you want to modify something, if maybe Algorand ecosystem CEO or their developer want to modify or some changes, they have to put in that ecosystem, and people will vote their proposal that this is the changes we want to do, and committee and the ecosystem will decide whether they needed that thing or not. So these are some features of DAOs. DAO use cases are proposal execution. If you propose something based on the voting, it will be executed, right? Funding for decentralized projects. Yes, if you need funding, you can put in the blockchain. People will see that your project is doing good, you are doing great. This is some worthy, you can say this is a good project. Based on that, you can get fund. Crowdfunding, if you have an NGO, so you can put in the blockchain, right? And decentralized DAO, and based on that, you can get crowdfunding and get funds from different people, from different countries. NFT-based investment, metaverse, decentralization, climate change, all these things you can. These are like use cases of DAOs. So this is all for today. Just because I know this is a very fast session, and this was basically an introductory session. If you have any questions, you can reach out to me. These are some AlgoBharat socials. You can scan and connect with us. And this is my, LinkedIn. You can directly connect to me if you need any assistance, any resources, any doubts. If you have, you can just reach me out on LinkedIn. You can connect, you can discuss, you can schedule a meet if you want. Yeah. So I'm open to your questions. If you have any question now, we have exceeded our time, but next 5 minutes I'm open to your questions. If you have anything, you can ask, or maybe you can write in the chat box if you want to talk. So thank you so much for joining, and I hope I have cleared all the topics. I know a lot of things, a lot of topics are still missing because we have just limited time. So yeah, thank you so much. Let's. If you have any question, just put in the chat box maybe, or you can unmute yourself.
Thank you, Mudasir. Guys, if you have any queries, just post in chat box, or you can even unmute.
Guys, don't be shy, right? I'm just your friend. I hope everyone is smart here.
Yeah, we have a question.
Sir, can you explain briefly what are the distinct traits of DAOs? I think this is not in this session, or you can say, Mikala, can you reach out to me on LinkedIn? We can discuss because we don't have enough time here. DAOs is basically, as I mentioned already in short, these are autonomous organizations for using voting and crowdfunding, all these things. So these are basically DAOs, you can say. Different between Ethereum and Algorand. Okay, so Ethereum, as I mentioned, that consensus is proof of stake, where you have to stake some Ether. Ether is a Ethereum native token. You can say Ether coin. So you have to stake Ether coin in the Ethereum network, which is on a consensus, which is basically uses the proof of stake consensus protocol. But in Algorand, the consensus protocol is pure proof of stake. Because what the problem in proof of stake is in Ethereum is, if you stake more Ether, if you are locking more Ether, like let's say 100 Ether, you will get higher probability, you will get higher chances of validating the block in the blockchain. So you will get more reward, right? So if I log 100 Ether and Akash log 10 Ether, so I will get more chances. I will get more probability, like my probability will be get high, right, to add in the blocks in the blockchain. And so that the reward will be distributed based on my participation, so I will get more reward. And maybe what happened, let's say I am corrupt, I have done something malicious thing, so that thing also a problem in Ethereum. So the proof of stake lacks that thing. In Algorand, it's based on pure proof of stake. I will explain tomorrow how exactly this works. But for example, in short, proof of stake is not based on people staking, but let's say for in Algorand, you have to basically you have to do a transaction, and you will get a validator basically. But let's say I have 10 algos, I have staked 10 algos, and Akash have staked 100 algos. Both persons' probability will be equal. Like just think this, not the probability of person is increasing, my probability and Akash probability will be same. But when I am when I am staking algos, my algo token probability will get changed, right? In Ethereum, let's say there is person A and person B. Person A is stake 10 Ether and person B is stake 100 Ether. So the probability is based on that person contribution, not on the token. Not on the token probability is changing. But in algos, the probability will change based on tokens. Your token will participate. Your token will get into that particular, like let's say I have 10 algos. So my 10 algos all are basically will be part of that thing. Not my, you can say that person. So this is basically a short definition. I guess, like, I'm sure like you didn't get what I want to say, but yeah, the distribution, or you can say validation here, is based on VRF. This is basically some random verifiable random function. Using that VRF, people get selected, or you can say block, that particular coin gets selected. In Ethereum, it's based on person, right? Explaining again. I have not cleared it. So in Ethereum, it's based on people contribution and people get selected. But in Algorand, your token will get selected. Let's say I have staked 10 tokens and someone else have 100 tokens. So my all tokens will get into that particular VRF, and some random function will run and my token will get selected, not me as a person or as an address, right? So in Algorand, this is 3 to 4 steps process. Like committee is selected, token gets selected using the VRF, then committee will validate the token is good or not good. What I mean by good is the transaction is valid, all the information that particular transaction is valid. So community votes basically, and after that there are a lot of process. I can explain in our next lecture tomorrow. So how the hash algorithm actually works in security purpose in every blocks of blockchain, why it is used to hack the system. So in the blockchain, basically uses the SHA-256 algorithm, SHA-256, the hashing algorithm. So hashing algorithm is basically a one-way function. You put something on the hashing algorithm, you give a data input. Let's say I have given some XYZ. It will generate a hash of that XYZ, which cannot be reversible. So if I have the hash of that XYZ, I cannot get that input value. So that's why hashing algorithm are used, so that no one can get the actual value of that input, so that it will be encrypted, right? So that's why we are using it increases security, because you cannot get that input. If you have a hash, right, you can validate, right? So that doesn't mean that you can use anything, any data you put on the hashing algorithm. No, because you have input, you can validate. And for the security perspective, you can use that hash so that no one can get your input. But yeah, for validation, you have to use that input, right? So for security, we have used SHA-3, SHA-256, and there are a lot of hashing algorithms. But generally, SHA-256, you can search SHA-256 and you can basically read all the topics, how exactly it works. Basically, it's one function. And if you are giving some input to SHA-256 or any cryptographic hashing algorithm, it will generate a hash and which cannot be reversed, right? Any more questions? Thank you, Surpita, for asking, and thank you, Keshav. I'll wait for just 2 more minutes if you have any questions, or maybe if you want any resources. I have few books on blockchain I can share. You can just DM.
Mudassir, I think Soumya has a second question.
Oh, okay. Is the hashes always changing after every transaction? Yeah, so this is one more property of hashing algorithm is if you are basically changing single entity or just anything in that particular thing, the hash will change. That's the thing, the hashing algorithms. So yeah, for every transaction, the hash will change. Okay, maybe there was an website where you can generate hashes. I'm not sure. Supriya, I can share the link. What was that website? I forgot. But yeah, you can just search some hashing algorithm website. You can see if you are just changing a single digit or single word of that particular input, that the complete hash will change, right? So while adding the block, every block has different hash, because that's why that if you're adding new block, the property will change, right? And maybe tomorrow I will show you how exactly these things works, how the hashes, how the previous hash and all this in the block property I can explain. So every block has few things they have to store. In every block, there are nonce, there are timestamp, there is previous hash, and the input value, which you are basically storing in that block. So these things are stored in every block, right? So if you are, let's say, Genesis block is block number 0. If I have stored in that block and the whole data is put into the hashing algorithm and it generates some hash, right? So the hash of that block is what I have generated. So what I will do is the generated hash I will put into our next block and I will name that as previous hash so that I can trail that. Let's say block number 1. In block number 1, I have put previous hash as the hash of block 0. So when I want to check like block 0 details, I will just put that previous hash which I have put into the block 1, so I can get all the details of block 2, right? So in every block, no, I'm not talking about this, but yeah, maybe this can be a hash generator. But I was talking about just give me 1 minute. I will sure just. Like if I'm changing anything, any space I'm putting or anything, the hash is changing, right? So this is the property of hash. This is shadow. This is hash. If you are you're putting something on the blockchain, for changing in every single entity, the hash will change. So let's say I will. Okay, let's first see that block. So the block have these things: data, nonce, values, nonce, this random number which miners have to generate in order to validate. So this is block 0. This is basically structure of block. Let's see a blockchain. So why I want to show you this. Let's say I put some data into this thing, and you can say the previous hash is 0 because this is block number 1. There is no previous block, right? So the previous hash is 0, 0, 0, 0, and the hash of this current block is let's say I mine this block. Mine is basically validating this is my block, right? So now you can see the hash of this block. That exactly I was explaining before. The hash of this block will be the previous hash of this block. So what is the benefit of this? So that if someone wants, let's say, this block, so I have mined this, right? So I'm validating this block is correct, everything is correct, the data is correct, and these are adding into the box. You can see it will changes its color because it's validated, right? So these two blocks are connected now because the previous hash, this is the previous hash, and if I follow this hash, this is exactly same as this. So if I want to get the basically, if I want to know what exactly the previous hash, I will just search this, and I got all the information about this. And the hash of this will be added to this, so something like that. You can say add into the next block. So if I want to change anything, you can see the color is changed because I modified that block and the hash is changed. And if the hash is changed, it will not match the previous the other hash, right? Yeah. So it was before 00000. So I am changing some. I have made some changes. It will get changed. So I have mined that thing in different hash, right? So if I make some changes, it will just get rejected. I will not be longer that. But that's why blockchain you cannot modify the things we have already put in the blockchain, right? So this is a property you cannot change because it's already linked. These hashes are linked to each other. You cannot modify. So that's why. So yeah, this is a website you can also play this. I see. Sure. Why can't we backtrack? We can backtrack that particular thing because every block has its previous hash, right? So okay, you are saying that why we cannot get that input value, right? So no, we cannot. As is a length same after each letter is taken as input. So you cannot guess, because maybe your input is the length of hashing that particular output is same, but that doesn't mean you can, because it's like 256 square diagram, 64 hexadecimal characters, right? So you cannot guess what the input value, because that the algorithm is made that way that you cannot guess what exactly that the input is. So yeah, I hope your doubts are cleared. If not, you can anytime you can reach out to me.
Thank you, Mr. Kasif. Thanks for your time.
Thank you for joining us.
There will be a continuation session of this tomorrow at 11 to 1. But at first, we will be explaining hands-on by Mr. Sunil. Later, again, Mudasir will be taking up. So first, we'll be demonstrating the hands-on session. Yeah, Mudasir, please.
Yeah, thank you so much for joining, and yeah, let's deep tomorrow also. And meanwhile, if you have any questions, you can just reach out to me anytime. Thank you for joining.
Thank you guys.